What's up, guys? So right now I'm just gonna make a quick video and the basics of a boiler system, so that if you have a hydronic boiler in your house, you have an idea of what's going on. So let me just start with some basics here as far as gas and your main. So this is your gas meter, and right here tells you the cubic feet per hour of the meter. That's a gas valve. That's a shut-off valve. This is your water main. It looks something like that, and usually you have like a copper wire grounded to it, and then that's a ball valve for the main, and it's going into underground into the city, to the outside. So if you didn't know, and usually we have to know about this, and we need to know about the cubic feet per hour as far as HVAC guys, and where the main is, and city water pressure. But this is mostly for the plumbers, but that's good for the homeowner to know in case they have an emergency. These valves here, you're gonna need like an adjustable or channel lock to close it. Right now it's open, it's vertically, it's going along with the pipe, but you need a wrench to turn it, and it'll be horizontal that way, depending on how this is placed. That one is open, and if you turn it, and it's the way it is now, you turn it horizontally, then it will be closed. So yeah, because I know a lot of customers get they think the HVAC guys do all the plumbing, and no, we don't do all the plumbing. Plumbers do plumbing, domestic plumbing, gas lines. Some companies, big companies, they have plumbers and heating and HVAC guys. But if you're just HVAC, we do heating and air conditioning. Some guys do refrigeration. So just keep that in mind, because some customers call me and ask me, about toilets and stuff like that, and then they get mad when I tell them I don't do toilets or sinks or domestic plumbing, or if you need a new gas line. So just keep that in mind. Or like the spigots outside for the hoses, that's the plumber. Anyway, so I got my combustion analyzer telling me if it's safe or how it's running, if it's burning clean, or if it's high carbon monoxide, or how the air is, the percentage of the air, oxygen or CO2. Anyway, I tested that and it's looking good. But I'm gonna go over some basics so you can know what your plumber's talking about, or your HVAC guy. So this right here, this feeds the boiler system. It's a fill valve or automatic water feeder, and you set it. It comes 15 psi, but you can set it from 10 to 25 by taking this off and screwing it counterclockwise or clockwise. You can set it to whatever you want, and then you'll know, either you have your own gauge or it'll tell you the pressure right there, psi. And then you have your ball valve right here. This will shut down the cold water going in. So this would only fill if you manually drain the boiler, or if there's a leak somewhere in the system. And there's baseboard here, so if the baseboard leaks or something, this will keep feeding it, so you got to be careful. Navient's boiler, they have a feature where you pipe in the cold water going into the boiler into the Navient. It's a different port, and then the Navient will feed it, or some other high efficiencies have it, boiler, but it'll feed it, and if it feeds for too long, it'll shut it off, which is pretty cool because it saved the house from getting ruined. So that's the safety feature. This will just keep feeding to 15 psi. This right here is a backflow preventer. So let's say you're in your house, for some reason, basically you don't want the boiler water to back up into your city water or your potable water for your showers, or your sinks, or whatever you have. So it'll release it through here instead of backing up into your domestic water or potable water. So that's another safety. Then you have your expansion tank here. I spoke about this in another video. This absorbs the pressure from the boiler. If you don't have this, the pressure will go over 30, and that valve there will start leaking. And then we have a little valve here in case we got to change it one day. We'll just spin this off. So there's a formula to find your static pressure for the type of tank you need. I just put the same one here because we don't have high static pressure, so I just put that one back. But if you're in a huge house and you need to do the math, there's a formula for that. Then we have, so you can look online for the formula. I don't know everything on top of my head, so I also have to look it up. Or the software. I know software gives you what you need if you're going to design something from scratch. Alright, so then you have this is a circulator pump. This is what circulates the hot water throughout the system. So this is pumping into the boiler on the return side, and then that's the supply. So it goes into the boiler, gets heated, and then goes to the supply that feeds the baseboard. And this one's electrically computated motor. It's supposed to save you money. After 7 days, it goes into energy saving mode. How it works inside, I don't know. I don't even know. I called Takeo, they don't even know. I asked them if they have sensors in there, and they said it has to have sensors in there, and maybe a little control board in there that senses the pump curve. There's other pumps that work off that modulate up and down, that work off a temperature difference or pressure. Those are a little more sophisticated for bigger homes or different applications. So then you have your relief valve. Like I said before, here you have, so basically this circulates the water throughout the system. You can place it on the return. A lot of guys like to put it on supply, depending on if you have room or not, or sometimes it's necessary to put it on the supply. A lot of engineers like it on the supply, but I put it on the return. And then if you want it on the return, it comes from factory, it would have been like on the back side. The face would have been on the back side. So you can actually take these Allen screws, take them off, and then spin it so you can make it work. But you just got to be careful. That's more advanced. I would leave that to a professional. Then you have the relief valve here. This right here is for safety. I mentioned this in the other video. If the pressure here builds up above 30, this will release water, and it'll keep doing that until you correct the problem. Then you have, this is a return from the baseboard, so it goes out of here. This is supply, goes around the baseboard and comes back here. And then this valve here allows us, isolation valve allows us to isolate the boiler, close it, but 9 times out of 10 we use it to purge the lines. It has a drain port here, and this little valve here to let the water out. So mostly we use these on returns to power purge. We get rid of the air that way, whatever air gets into the system. And then the air gets into the system by, whenever it feeds here, whenever the water feeder feeds, there's air bubbles in the city water, so over time it accumulates, and then you get an air pocket in the baseboard or in the pump, wherever it forms. So we got to purge it from here, or when you manually open the system, you introduce it to atmospheric pressure, and you get air in there. Okay, that's another return valve for power purging. And then this right here is a vent, this damper vent. This right here is supposed to save you money, because when the boiler shuts down, it has a little damper in there, and it closes this way, and basically it doesn't allow the heat to go through the chimney, or heat transfer. Basically, it prevents heat transfer from the boiler to the outside. Now, it's supposed to save you money, but these things go bad, and then it costs money to fix it and repair it. So it's like pros and cons. But the boiler won't run without this working. It's also a safety, because the boiler, if it starts running and this is blocked, the combustion is going to come back into the house or the space, and it's going to be a fire hazard, not a fire hazard, but it's basically exhaust fumes coming into the space. So if you're a professional, never bypass this. And then here we go. This is a air vent, spiral vent. This eliminates air automatically, so it prevents those little air bubbles from the city or in the water from forming. There's a little diaphragm in there. It pushes the air out of here. And this, I like this. Usually the manual tells you to put it further away from the elbow, but I didn't really have room here. So yeah, and then we plug this. Sometimes you can go with you could tap here. You could tap here and install your expansion tank on the bottom of this. That's what that's there for. Okay, what else do we have here? And then of course you have your chimney, your flue pipe, which goes up there and out to the roof. This is an on-off switch, which I changed the switch. I changed the cover for this. I changed an outlet here and the cover. I didn't change the boxes because that's the electrician, and that would have been, it's a lot more, it's very time consuming. So I just changed the switch and the plug so that we don't have a problem with the switch, because the switches go bad over time. Then I ran this BX here and the low voltage wire with this thermostat. Of course, you know the thermostat, it basically it turns the boiler on. It acts like a switch, so when it calls for heat, or when the actual indoor temperature goes below the set point, which right now 65 is the set point, we can raise it or drop it. But if the temperature goes below 65, it'll turn the boiler on. Right now the boiler turned off because it hit temperature. So this right here, you can set this, you can set the boiler temperature, which for the Northeast usually was 180. And then this down here, that's the temperature that you allow the boiler to drop down to before it turns back on and reaches 180 again. So just because the flame and the boiler is off doesn't mean that this pump is off. This pump keeps running to meet the 65 that is demanding right here.